Now let's have a look how to do correlation analysis in Excel. There are a couple of ways how to do that. Just like with many things in Excel, there's more than one way to do something. I'm gonna show you one. So for this way, you need to make sure you have this plugin, data analysis plugin. We're gonna be working with it quite a bit in the following sessions and in this session as well. So how do you get this extra button here if you don't have it? You go to File, Options, you look for add-ins, and then you see analysis tool pack and you add this one. So I already see that I have it added, so you need to make sure that it's active, and then you click OK, and after you close everything, open it again, or maybe right away, depends on what kind of version you have. You will have this button here. Of course, if you close everything and open it again, make sure to save everything you've done so far. And now we're going to do correlations. So for this, like for most of the analysis that we will continue on doing, you will need to create a pivot table. So let's have a look whether there is a change of GHG values along years. So basically, is there a correlation between time and GHG values for Austria, for example? That's what we're going to look at. So we need to look at the relationship of the variable time, in this case year, and the variable value. But we need to sort out a little bit because for now we have all the countries. So therefore, we go to Insert and we create a pivot table. What I would like to see is all the years listed and my values listed, ideally just to be sure an average. And let's make a filter because we only want to look at Austria. Select Austria and click OK. So again, year in rows, and we have all the years here, values of GHG here, and party as a filter, and it's set to Austria. What we're going to do now, first of all, we're going to kill this grand total because it's not gonna help us when we're gonna start selecting the fields. So how we do that, we go into the design of the pivot table. You need to be standing on the pivot table for this to happen. Grand totals, and click grand totals off. Scroll down to see if it happened. It did happen, so we don't have any totals right now. We are ready. Now we're going to see whether there is a correlation between this variable, time, and values of GHG. We are working with the data and we're full on in the analysis, so we go into the Data tab. When we use our new button here, we select correlation. I already played with it a little bit, so it remembers what I did before, but we'll start again. And you select both fields that you would like to correlate with each other. And then that's it. So we have both fields selected. You click OK. And something's wrong. So it tells us that actually years is not a numeric variable. At some point, probably at the beginning of the original, it was recorded as text, and we missed it. I missed it, and therefore it's dragged along. We can go back and look and try to reload everything, or we can do a not so smart but a quick solution. We select our years, click Ctrl C, click Ctrl V to copy it here. See, this is exactly what happened. We have an error. It's number sorted as text. Let's convert it to numbers. So make sure that you have selected all these copied values here. Go on this eye icon in the drop down menu and say convert to numbers. So now it's numbers. Let's press escape and try again. Data, correlation, remove what we had here before and select our new value. I'm going to use a shortcut, Shift, Control, and arrow down. So I have both of them selected and I click OK. So we produced our correlation table and we only have 3 values here. So first of all, let's keep it clean. We have our long value here, and we have our pivot for correlations here, so let's rename it. And this is our correlation analysis. We'll decide later whether we keep it or not. So, but now we can name it as time Austria correlation. So this is the correlation of time in Austria. In the other cases, you will see that we can include labels so that this table is a little bit more readable. The thing is that for correlations, for assessment of the correlation, we need two values, and we only have one. So we have a correlation between time and GHD values, and what Excel produces is the Pearson-Arc correlation coefficient. So we can assess the strength of the correlation, and it's quite strong. But we cannot say whether it's significant or not. Of course, if the correlation is strong, the chances are that it's also significant. But we would like to have a p-value on it. Why on earth a data analysis tool in Excel does not produce a pivot value for us by default? Well, it depends. In general, there is quite a discussion about whether we should or shouldn't look at p-values. So it could happen that in some analysis or in some analysis tools, p-value production will not be a default setting. The program will not print you a p-value by default. For some reason, for correlation in Excel, that is also the case. That doesn't mean that we cannot get a correlation. There is always a way around it. And I already found a cheat sheet for it, so let's have a look and you follow along. Of course, you do not have this formula here. So we have two steps to calculate our p-value as it's shown in the example here. First of all, we need to figure out what is our sample size. That's not a difficult one. If we select the column, we see that the count is 29. So we have 29 years between 1990 and 2018. And this is our sample. So let's write n and say 29. Now let's calculate the t-value. So here it shows us that we need to select the Pearson correlation coefficient, multiply it by square root. This is a square root formula. Square root of sample minus 2. You don't have to know what it actually means. That has something to do with the degrees of freedom. If you read the first two chapters of Andy Field book carefully, you probably have seen that he talks about degrees of freedom here and there. For us, this is just a tool, so you don't have to go and figure out how exactly it works. Let's just follow along and use it as is. So now we divide it by the square root of 1 minus Pearson correlation coefficient squared. So this little hat and then number 2 after it, that will mean squared. So B3 squared. And we produce the t-value. T-value already tells us a little bit about the relationship. We might touch upon it later, but generally bigger t-values is a high likelihood that the result is significant, but let's not mock around and just produce a p-value just so that we know for sure. How do we produce a p-value? So there is a t-distribution two-tailed function, and we are plugging in the t-value there, and again sample minus 2, the same degrees of freedom story we had before. So p-value seems to be much smaller than 5%. Therefore, this relationship between time and GHD values is positive and significant. So what does it mean positive? As time goes by, so as the year count increases, so does the GHD values for Austria. So actually the rate of the GHG, so greenhouse gases in Austria are increasing over time if we look at the time frame between 1990 and 2018. We can also have a look at more values at the same time. To do that, let's go back to our original pivot table. Let's remove this because it will get removed as soon as we start playing with it anyways. And let's throw it into columns. So now we have all values, all countries here, all parties involved. Let's use the filter here to select the countries we might be interested in. So let's say, let's keep Austria. Maybe let's drag Germany in. And let's also include Russia. Why the hell not? So we have these three values here, and we can run a correlation on all the three countries together, or countries plus the year. So let's change the label here so that it nicely says year, and then we can include labels. So you step on it and you press F2. Now we can type in here year. And let's make a correlation and see, optimize it and see the correlation of all these values with each other. Go back to the data and analysis. We're still doing correlations. Remove this previous field here, and let's select with the labels now this whole field, and let's not forget to tell Excel that we're using labels. And it gives us an error again because of course I forgot that these years are problematic. Never mind. We create another year column and we just copy the values here like before and convert them into numbers. Pressing escape, and second attempt in creating a more elaborate correlation table. Let's select Austria, Germany, Russia, and shift control arrow down. There we go. Labels are selected. Clicking OK. Let's keep it in order. Drag this new sheet here and say that this is Austria, Germany, Russia. Correlation. We have all kinds of correlation coefficients here, and now you see that the table is much nicer, so we don't have just column 1 or something like this. We actually have the numbers. And now it makes sense where the ones are coming up. So of course Austria correlation with Austria is 1. It's the same thing. Looks like Austria with Germany has a negative correlation. We already know that Austria grows over time, so we can say that Germany actually reduces its greenhouse gases. And as Austria increases its GHG values, Germany decreases. The same seems to be for Russia. Russia is also dropping in its values. You could technically assume that this is because both Germany and Russia care about the environment really much and Austria not so. That would be one interpretation, and if this is the story that you would like to tell, that is possible. However, there could be multiple other reasons for it, because it could be that in different countries these values are calculated differently, therefore they produce different things. It could be have something to do with the prior political events and with the production. So for example, you can have a look what's happening with Russia over time. It's dropping. The Pearson correlation coefficient is negative. The values are dropping over time. So GHG values for Russia, this is Russia, are lower now than they were before. And maybe that's not because Russia cares about the environment so much, but because since 1990, a lot of up to 2018, a lot of things happened in Russia. One of them is that in 1990, Russia wasn't Russia. Russia was Soviet Union. And since then, a lot of production went out of business because before that there was planned economy, and then there was a whole transformation from planned to other types and so on and so forth, and to the more a market economy and so on and so forth. So there are a bunch of reasons. These are just two of them why it could actually happen. It could actually look like Russia is so concerned with the environment and dropping its numbers, but in reality it's actually having economic problems that result in drop in GHG. So once you have numbers like this, you need to try to figure out what is actually going on and what could be the prerequisites for it. But now let's try again and calculate p-values for these numbers as well. So I'm going to pull out my cheat sheet again, put it here. What sample do we have? It's still 29 years. So we have n, that is 29. Now let's calculate the t-values. So we have t-value, and now we need to try to create them in the same order, then it will be nicely arranged and then we can replicate the p-values. So let's create two more tables like this. So we have t-values, and let's copy this bit here, this whole bit here, delete these numbers and start calculating t-values because we are doing t-values now. So again, we need to take Pearson correlation coefficient, multiply it by square root of sample size minus 2. And let's also freeze sample size because it's the same for everything. So let's put $2 on both sides of it. Now we divide it by square root of 1 minus Pearson correlation coefficient squared. Close the bracket and press enter. Let's drag this value everywhere and delete the unnecessary things. So here, of course, it referred to empty cells, hence zeros. Let's delete them so that they're not distracting. Here we have 1 minus 1, that's why it shows us division by 0. That's not possible. Let's delete those scary ones as well. Let's calculate p-values now. Let's copy our original top table again here. Delete these numbers. And look at our formulas. What should we do? So, Germany and Austria, we take a t distribution two-tailed formula. We select our t-value and then we say our sample, which we will freeze right away. That's not freeze, which we will freeze right away, and minus 2. Close the bracket. Oh no, what happened? So it turns out this formula does not like negative numbers. That's not a problem. What we can do here is say, let's calculate absolute numbers. There is ABS formula. If you put it on the outside brackets, you will see that all it does is removing 0. So let's drag this formula down a little bit here and here. Now we have all numbers that are positive, so this formula works again, and we can just drag it everywhere and delete the cells that don't make much sense. So we have these numbers here. They're again really weird numbers, so let's format this. Select all, format, number, and we want 3 values after comma. Everything is highly significant, so we already know that this is not an actual 0, that when we see something like this, we would write p-value is less than 0.001. So all the correlations are significant, and now we optimized it so that we can create many of them, and now we can make some statements. Maybe we can go look at the politics, at the history, and what was happening in the last 3 decades, and then we can actually find out what are the reasons behind it. So sometimes just common sense might be enough to try to figure out potential reasons for correlations. Sometimes you need to look things up. The important thing to remember is that correlation is not causation, and there could be multiple reasons for the same thing. So now it's your turn to play around and try to run some correlations and try to find reasons for them and whether they're significant or not.